Okay, this is my video reassessment for standard number 1. I chose this problem. A race car accelerates from 18.5 meters per second to 46.1 meters per second in 2.4 seconds. Determine the acceleration of the car and the distance traveled. So our given information is the initial velocity, which is 18.5 meters per second, the final velocity, which is 46.1 meters per second, and the time the car traveled, which is 2.47 seconds. So we need to find the distance and acceleration. So first, to find acceleration, you use the acceleration formula, which is velocity over time, the final velocity minus initial over time, which is 46.1 meters per second minus 18.5 meters per second divided by the 2.4 seconds, which gives us 11.2 meters per second squared as the acceleration. So I knew that I had to use the given equation, one of the given ones that are on your website, to find the distance equation, but I didn't understand it. So I ended up Googling and kind of researching how you would derive it. So I found, and this actually helped a lot, learning how to do this, that if you put it on a graph, the velocity is the y and the time is the x, and the height of this is at. So in our problem, there was an initial velocity which would make the car start moving from at this point, which creates a rectangle right here, which the bottom would be the time passed, and the height is the initial velocity. So the area of a triangle is 1/2 base times height, which gives you the 1/2 at times the time squared. So the at in time would be squared. And then you would do the rectangle, which is just the initial velocity, which is the height, times the base, which is time passed, so t. So that gave me an equation to find the distance traveled. So from there, I just plugged in the information from above. So it would be the 1/2 times the acceleration, which is 11.2 meters per second squared, times time, 2.47 seconds squared, plus the 18.5 meters per second squared times 2.47 seconds squared. And then this gives us 34.1 meters plus the 45.7 meters, which total gives us our distance of 79.8 meters for distance.